Hey everyone, welcome back to the channel. In our previous lessons, we learned how to solve series and parallel circuits and how to use Kirchhoff's laws. Today we are going to something super important, that is power in electric circuits. Let's get started with the lesson. First, let's see what is electrical power. Electrical power tells us how much energy a device uses or delivers every second. Uh, I'll tell you what is the basic formula for this. P equal V into I, which is P is power in watts and V is voltage in volts and I is current in amperes. I think you got idea about the basic equation for the electrical power. From previous lessons you have learned what is Ohm's law. Ohm's law is V equal I into R. By using this Ohm's law, we can generate another two equations to calculate electrical power. I'll show you what are those two equations. Power equal V into I. If we know, we can substitute V from this Ohm's law. That is I into R. From this we can get equation P equal I squared R. This is our second equation to calculate power. And the other equation for the P equal V into I, from the Ohm's law, we can substitute I. P equal V into I means V divided by R. From that, we can get the equation as P equal V squared over R. This is our third equation. I think you got idea about the three basic equations to how to calculate electrical power in circuit. I will show how to calculate electrical power in these three from these three equations by using small example. Let's see. There's a power voltage supply of 10 volt and we have resistance of 10 ohms and the current flow is I. We can find the current flow through this closed circuit I by using Ohm's law. V equal IR. Then I is 10 over 10 amperes. That is 1 ampere. That is our I is equal 1 ampere. Now the power consumption in this circuit we can write as from the equation 1. I'll number these equations as 1, 2 and 3. By using equation 1, that is P equal V into I. Voltage is 10 volt and I is 1. Then we are getting as 10 volt. By using equation 2, P equal I squared R. We know I, that is 1 squared to 10. Again we are getting 10 volt. And by using equation 3, P equal V squared over R. We know V 10 and divided by 10. This gives again 10 you can see if we know any two of these voltage or current or resistance, we can find power of an electrical circuit by using these three equations. I think you have understood this simple concept, and I want to point out to you some important points regarding this power in electrical circuits. Let's consider power. Let's see the difference between power in series and parallel circuits, right? You know that power behaves differently in series and parallel the circuits. In series circuits, same current flows, and voltage divides, and devices may get less power because devices getting less power because the voltage is dividing. That's the reason, because the same current flows but voltages for different devices will be changed. And let's see in parallel circuits. In parallel circuits, same voltage across each branch, and but the current splits because we have discussed in previous lectures how these current splits, and each device gets full voltage. Therefore, usually more total power is used in parallel circuits. I think you got idea and the difference between the power in series circuits and parallel circuits. To summarize the today's lesson, as a summary, you learned that power equal voltage into current, and from this basic equation we have find another two equations as P equal I squared R and P equal V squared divided by R. And power tells us how much energy is used per second. This is the basic definition for the power, that is, power tells us how much energy is used per second. And at last we have learned series circuits lower power and parallel circuits increase it. That's all for today's lesson. If this lesson helped you, hit that like button and subscribe for more. Next time we can learn voltage and current divider rules or AC circuits basics. Comment which one you want. See you in the next class. Thank you.